Okay, I'm here continuing this problem that has 6 parts to it, and I think I'm on part C now. And in part C it says we're proving this statement false, and the statement in part C is that A minus B intersected with C minus B is equal to A minus the union of B and C. And so I'm going to do the same thing I did for part B. I'm going to draw the complete, what I call the complete drum set of A, B, and C, and show that the regions specified by the left side and the right side are different. So A minus B intersects C minus B. So part C, A minus B intersected with C minus B. And that's the left-hand side, and the right-hand side was A minus B union C. A minus the union of B and C. And basically all I'm going to do is take the left-hand side and figure out what set it's talking about, and do the same thing on the right-hand side. And I think we'll see that the sets do differ. And so we're going to start with this, A, B, and C, A, B, and C. And let's start with A minus B and C minus B. A minus B is this thing here in red. So in red we have A minus B, where I've taken the set A and I've subtracted off the set B. And C minus B I'll do in green. C minus B is this thing, sort of another moon-shaped segment. And I'm going to take the intersection of those two, and I guess I'll color that black. And the intersection of those two is this little region here. Okay, so this little region is A minus B intersected with C minus B. Okay, now on the right hand side, let's start with red again, and we'll do B union C next. B union C is everything that's in either B or C. And now I want to take A minus that. And so A minus that is going to be in this one. Let's see, I'll make it black again for the final thing. A minus that is going to be this region here in black, and I'll shade that in black now. If I can do it properly. And now here's the right hand side, which is A minus B union C. And you can see that clearly these two are not equal. Therefore this is false. Okay? I'll put a little F up above the equal sign. So we've just disproved this statement. Because if we make this statement, that means it has to hold for all possible sets A, B, and C. And in fact, when I draw what I call the complete drum set here, we do have all possible combinations of A, B, and C. Okay, so that's part C. Let's see if I can fit part D into this video also. Part D says, if this and that, then something else. If A intersects C is a subset of B intersects C, let me start with blue again, part D. If A intersects C is a subset of C intersect D, if A intersects C is a subset of B intersects C, B intersects C. B intersects C. B intersects C. And what else? And A union C is a subset of B union C. A union C, B union C. A union C is a subset of B union C. Then A is equal to B. union C is a subset of B union C. Okay, so this is an if-then statement. And in order to prove an if-then statement false, we need to show that we can come up with a situation where the premise is true and the conclusion's false. So let's try to come up with a situation where the premise is true. We have A intersect C being a subset of B intersect C. Why don't I make A a subset of B to start with? A, B, and then A intersect C will be a subset of B intersect C. And I also want to make A union C a subset of B union C. I think I can just go like this. Yeah. A intersect C is going to be in red. A intersect C, right? And I'll make in green B intersect C. B intersect C, well, C is a subset of B, isn't it? And so B intersect C is equal to C. There's where C and B overlap. Okay, and so indeed, so let me underline these with their colors. So this one's true. And now, is A union C a subset of B union C? Well, it is, and I guess I'll try a different colors here. Well, I guess I'll use a thick red line for A union C. A union C is this, right? Can I make it? That's as thick as it gets. This is A union C. It's the thick one. And B union C, because the thick one here, because C is a subset of B, B union C is just B. Okay? And so A union C, the thick red line, really is a subset of the thick green line. So both of those are true. But does A equal B? No. Okay, so this does it. This actually does it. And let me, so this proves it. Okay, so all of these things are true, but A does not equal B. Okay, and some of the facts I used along the way were on B intersect on the left-hand side. When C was a subset of B, that implied that B intersect C is equal to C. And on the right-hand side, one of the facts I used was that when C was a subset of B, then B union C was equal to B. Okay, these are important facts that you should be able to convince yourself of just by drawing a couple quick diagrams. Okay, so that should do it for part D, and I think I'll stop here on this video. Hope that helps.